Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE MLR IT. So this is the video about the introduction of 8086, which is the part of the series Microprocessors and Microcontrollers. Today I'll discuss what are the major features of 8086 and how many data lines and address lines are there and how many interrupts and how this microprocessor works. So coming to the features of 8086, actually in the previous video I have already discussed about the 8085 microprocessor. How it will, what are the address lines, data lines. If anyone didn't watch the previous video, please do watch that video because that videos are the basics of 8086 microprocessor. If you know that basics, then only you are able to understand this concept, 8086 microprocessor. So basically 8086 is the enhanced version of 8085 microprocessor. So most of the all the features which we are already discussed in the 8085 is also in 8086. Apart from those features, there are major features in 8086. So today I'll discuss what are the major features from 8086. So 8086 microprocessor is designed in the year 1976 by the Intel Corporation. So it is a 16-bit, first 16-bit microprocessor, which is a huge commercial success in microprocessor. It is a 16-bit microprocessor. As in the previous video, I have already discussed it. What is the bit processing? So here, this is the 16-bit microprocessor, which needs to support three basic things. First one, it should always have the data lines of 16-bit. So the data line starts from D0 to D50 and it must have the internal registers of size 16-bit. And here 14 internal registers are there in 8086 microprocessor. And the last one is it should access 16-bit of data at a time. So basically 8086 is a 16-bit processor because it supports 16-bit data lines. It is having 16-bit internal registers to store the intermediate values and it can also access 16-bit of data in one machine cycle. By using this 8086 microprocessor, you can fetch 8 bits of data. Out of 16 bits of data lines, you can use 8 bits of data lines to fetch 8 bits of data in one machine cycle. So 8-bit of data which is accessed by 8085 can also be accessed in 8086 microprocessor. So, a 16-bit microprocessor is having the importance that it can access 16-bit data as well as 8 bits of data in one machine cycle. And here it is having 20 bits of address lines. As I already told you, the address lines always fetches the memory it could access. So 8086 is having 20 address lines. So we can say that it could access 2 power 20, which is nothing but 1 megabyte of memory. So 8086 can access 1 megabyte of memory up to 1 megabyte of memory. So the address lines are from A0 to A19. Here if you see that the data lines is of 16 bits, data lines is of 16 bit and address lines are 20 bit. Address lines are 20 bit. These data lines D0 to D15, total 16 data lines, and address lines A0 to A19. Out of this A0 to A19, A0 to A15 is multiplexed with data lines which will become A0, AD0 to AD15. So the remaining 4 address lines will be from A16 to A19. These address and data lines will be multiplexed because 8086 is a 40-pin inline package. So it will have 20 pins this side and 20 pins this side. Out of 40 pins, if we are need to give each pin for data lines. It would have 16 pins only dedicated to data lines and 20 pins only dedicated to address lines. So total 36 pins. Out of 40 pins, we need to use 36 pins only for taking the address and data lines. So which will occupy more space. So that's why it have been multiplexed. Some delays will be there by using the multiplexed, though 8086 use multiplexing of data lines and address lines. So this is the 8086 40 pin inline package. So it already 1986. Coming to the another important feature is 8086 can generate 16-bit input-output address. So by using input-output address, we can say that particular microprocessor can access these many input and output devices, input and output ports. So 8086 can access 65,536 input-output devices at a time. So if 8086 is here, it could have attached to the input devices like keyboard, output devices like printers, memory devices. Like that, it could access 65,536. By using input-output addresses, it can access 2 power 16, which is nothing but 65,536 input-output ports. So as I already told you that 8086 uses multiplexed addresses and data bus, which reduces the number of pins needed but does slow down the transfer of data, because at a time it could access only as a data lines or it could access only as a address lines. So 8086 microprocessor can operate with the operating frequency of 5 MHz to 10 MHz. In 8086, there is 3 versions of microprocessors. 8086 operates with 5 MHz of frequency, and 8086-1 will access 10 MHz of frequency, and 8086-2 will access with 8 MHz of operating frequency. These are the series of microprocessors comes under 8086 microprocessor. And 8086 microprocessor is possible to perform bit operations, like you can give binary operations or anything. So it could multiply. This is a 16-bit operations. You can, it is a bit operatable and byte operatable. You can give byte operatable, and you can give word operatable. It can be byte operatable, or it can be block operatable. Block operatable means, so we are having 4 bytes of data in one memory. So I can perform that, takes the first 4 bytes of data from this particular memory following the particular unique addresses. If this is the unique address of this location, I could fetch the data which is present in the microprocessor by giving the unique addresses. This can be the block addressable or block operationable. So 8086 is a microprocessor which can be performed by using bit operatable, byte operatable, word operatable, and block operatable. It performs the arithmetical and logic unit which is performed by the ALU in the 8086 microprocessor. It can perform multiply and divide operations also. So coming to the next important feature. So 8086 is designed to operate in 2 modes, which is minimum mode in maximum mode. If the CPU is having only one microprocessor 8086, that is the minimum mode. If the CPU is having more number of microprocessors, minimum number of microprocessors is 2, and more number of microprocessors, that processor will come under the maximum mode. So 8086 can be operated in 2 modes, minimum mode and maximum mode. Here we are having one important block in 8086 microprocessor, which is the queue. Queue is the block which is used to fetch the instruction and use it to store this instruction in this queue. 1, 2, 3, 4, 5, 6. This queue is 6 byte register, which is used to store the next instruction. So here microprocessor 8086 is implementing the pipelining concepts, but it in the 2 stages pipelining concepts, which is fetching and executing. So this prefetch operation, what we are talking as a prefetch operation, fetching the next instruction and saving it in the queue. This is the queue which is used to prefetch the instruction and store it. This is of 6 byte. So why this 6 byte? Because the maximum size of one instruction in 8086 is 6 byte instruction. So to support that 6 byte instruction, the queue is designed in such a way. So it can hold one maximum size of instruction in 8086. The minimum size of instruction would be the 1 byte. So 8086 uses 2 stages of pipelining, which is used to fetch the instruction and then execute the instruction, which improves the overall performance of the execution of 8086. So fetch stage can prefetch up to 6 byte, which is used by the queue of instructions and store them in the queue. So next important one is microprocessor 8086 is having powerful instruction set, which can be supported by the different addressing mode. It is having register addressing mode. The operands which can be used in that particular operation can be stored in 2 registers, and immediate addressing mode, which one of the operands should always be the raw data. Raw data we can perform using this immediate addressing mode, and direct, we can give direct address of that particular memory location. Indirect, we can give the address which is already stored in the register or memory. It is an indirect way of addressing modes. And indexed base addressing modes, which is always used to calculate the 20-bit address, which is used 8086 will calculate that. In indirect addressing mode, we are having based indexed registers, relative and implied addressing modes. I will address this addressing modes in the separate topic after architecture of 8086. So next, coming to the next one is interrupts. As I already told you, interrupts is the instruction. Interrupts are the external events causing the disturbance of flow of execution of the program. So here in 8086, any interrupts is having 2 types of interrupts, hardware interrupts and software interrupts. Here the hardware interrupts of 8086 having NMI, non-masked interrupt, and INTR, interrupt request. This non-masked interrupt is the highest interrupt, highest priority in 8086. If this non-masked interrupt occurs in 8086, 8086 will stops the execution of any program and attends these prioritized interrupts. So here in 8086, we are having 2 interrupts, NMI non-masked interrupts and INTR interrupt request. And the software interrupts which we are using in the 8086 is of 256 software interrupts are there in 8086. These are the basic features of 8086. So until now we have discussed about what are the data lines we have been using and what are the address lines we have been using in the 8086 microprocessors, how queue work in the 8086 microprocessors, how many input and output devices can be accessed by using 8086. Input output devices can be used accessing the 8086 microprocessor, and what are the interrupts. Just brief introduction to 8086 I have discussed until now. So in the upcoming video, I would like to discuss the architecture, very important thing, architecture of 8086 microprocessor. Thank you.